Hello and welcome back to Doz's Television Workshop, where today we're going to be taking a look at this fantastic Philips 17TG100U 405 line System A black and white TV set. Right, the 17TG100U, very popular set, came in Philips and Stella and maybe another couple of brands as well that Philips owned. This is the Philips variant. 405 line black and white set, 17-inch tube. Also came in a 19 and a 21 at least, possibly even a 23 later on in its life. We've got a band 1 and 3 VHF tuner down here for BBC and ITV, on-off switch, and a concentric brightness and volume control. Now, we're not just going to power up this and hope for the best, because that's a daft thing to do. A bit dusty and grimy. By the way, it came from my mate John, who's sadly closing his shop, and this has been sat in his workshop for goodness knows how many years. But yeah, he wants to see an episode of Doctor Who running on it, so that's our goal. Obviously, I can't show that on YouTube because we shall upset the copyright gurus. But yeah, we'll get some pictures of some description on it, hopefully. We need to run a few tests before we put mains up it. We want to make sure it's at least complete, electrically safe to continue. We shan't just drop mains onto it. We shall run it up slowly via the variac. Things we need to test to make sure it's viable. We need to test the picture tube because we will never find another one, I shouldn't think. So we need to check that. The other thing that might condemn it is the line transformer, and sadly until we get it running we really won't know. But we can take some precautions by trying to dry out the line transformer. Depends whether it's a sort of pitch covered thing or it's plastic insulated. If it's pitch covered, we might be in trouble. But yeah, we will see. So yeah, spin it round. Let's test the CRT before we go any further than that, and maybe work on some method of heating up the line transformer. If it's a pitch covered one, they get hygroscopic and absorb moisture, so if we can drive that out, it gives our high voltage winding a chance. Although from what I've read, I think it's the primary that fails on these, but well, let's see how far we get. Right, the rear of the set, aerial socket, VHF bands 1 and 3, mains voltage selector, 200 to 250 volts in 3 different taps, so 210 to 200, 230, 220, 250, 240. 3 pots on this side, contrast, vertical hold and height, and on the other side horizontal hold and the interference limiter. It's complete with its mains lead. How many of these have got lost over the years? Complete with lots of dust. It's a sort of 2-pin diagonal affair. Right, we need to get the back cover off. Those are 4BA, which is actually your ordinary hex screwdriver end size. So you just pull those out. I think there are 2 underneath as well. So that one's already loose. Okay, I believe there are 2 underneath here. Ooh, yeah. Right, what horrors lie beneath? 2 screws there for a start. They made sure this back was held on, didn't they? Are we away now? Yes, of course. There we are. Well, it looks fairly intact. I would like to date it, so hopefully some of these capacitors will have dates on them. The chassis should swing out somehow. work out how that does. This says latch, that says hinge. Well, that seems reasonable. So, do we have to unscrew the latch, I wonder, or does it just lift up? One of life's big mysteries, perhaps. I reckon we must have to unscrew one of those to get the latch to operate. Yeah. So, did a little bit of research. This set was released in 1959. So, that's quite a neat idea. A bit of plastic around it when it was original. There we go. Let's take that out. Then we should be able to hinge our chassis out. Oof! Oh, that's always an interesting sight to see. Can we see that on the camera? Just about. I might just get the other camera in by hand. You can see these droppers have got what they call polo mints attached, and as the dropper resistor blew open circuit, your TV repairman would come out and put a polo mint across it to bridge out the open circuit section. So yeah, handheld camera footage. Sorry about the wobbliness. Plenty of dust in here. Bottom of the cabinet. I don't know. I've seen worse. But yeah. So there we are. This is the polo mint department, as I mentioned it. These are the dropper resistors here. And what's happened is, you know, one afternoon that section's failed, so somebody's come along and bridged it with an RS polo mint resistor. There's another one there and one there. So we'll have to do something with that to tidy it up. But just for now, it's probably going to work unless some other section has failed open. There's our VHF tuner, 2 valves in there. IF stage down the bottom there, I would imagine. Yeah, especially as there's lots of coils and things there. We've got our line output stage down here. So there's our line output and boost. Oh, where are we? Boost rectifier up in there, and our EHT rectifier there. That's our overwind. Let me just switch a light on. So there's our line output transformer, or over the States they'd call that a flyback. So yeah, there's our EHT overwinding. It's not the sort of pitch covered thing, but I'd still like to pass a little current through that just to warm it up. But the first things first, what we're going to need to do is test this CRT, see if it's any good, and if it's not, well, we have to make a decision on whether we're going to carry on or not. So it's a Mullard AW43-88. We're going to use the leader CRT tester to see what its emission is like. Let's get on with that. Right, I've had a look in the instructions for the leader CRT tester. It doesn't list the AW43-88 tube, and not only that, but the adapters I've got are only colour anyway. So what we need to do is revert to the DOS Universal CRT adapter. This is just a load of crop clips, well, micro hooks, sorry, with the right labels on for the thing. Trouble is, they've all sort of gone smudgy under the bit of tape that they were when I made it years ago. G2, G3, right, anyway, so there we go. I've downloaded the datasheet for the tube off the internet, so what I've got to do is put these hooks on it, hook it up, and see what it's like. Okay, right, hopefully we've got this all hooked up correctly. Yeah, dust the neck off a bit so we can actually see the gun inside. This is known as a straight gun tube because the gun is not at an angle and fitted with an ion trap magnet. Also, it's got this rather interesting encapsulated coil arrangement, which apparently could be problematic back in the day. So let's see what we're going to do. There's some glare on this meter. I apologise, I can't really do much about it. Yeah, we'll see what we get on. Right, adjust heaters. So I should be able to see the heaters warming up inside the neck of the tube with any luck. Where are we? We're at 4.7 volts. Let's take that up a little. Okay, so that's at 6.3 volts. Yes, I can see a very slight glow in the back, so that's good news. Let's go for heater cathode leakage. This was a problem where the heater and cathode become one. Yeah, well, that looks good. First, grid leakage, none at all. That's good. We'll set the G1 voltage about 45 volts. What was that? Sounded like something went splat. I suspect it's just me. Set cutoff. So just as you do with a B and K, we have to set the cutoff. So we raise the red control in this instant until we see it cut off. Oh, it's quite sharp. Okay, there we go. That's the set cutoff. Read emission. The moment of truth. We want this needle to swing over into this green section. Oh, okay, we're in the questionable section about midway. Just try and shield the display from the light a bit. Yeah. Okay, in fact, we are falling. Why are we falling? That's not so good. Let's just go back round and check everything again. Heaters, 6.3 volts. Heater cathode leakage, next to nothing. First grid leakage, next to nothing. Set G1s at 45 volts. Set cutoff again. Let's just move that. Looking good. Read emission. Maybe not so good. Now what I'm going to do, I mean, this tube probably hasn't seen power for, well, the service was switched off in 1984. So that's the absolute last it could have produced a picture. So it hasn't been used for many years, nearly 40 years. So I don't know whether John ever attempted to power it up. So what I'm going to do is I'm just going to leave that on for a little while and see if our tube wakes up a little. So after over an hour now, our emission is still pretty grim. Let's just check we're adjusted up right. 6.3 volts, very little heater cathode leakage, which is good. No grid leakage. Grid 1 voltage still 45. Set cutoff, yeah, it's still good. Yeah, it's grim. We're way down here on the bad. I'd like to know why it came up first. But you know, the good news is there is no leakage, because that would have been a showstopper, or very little leakage. If I turn that down a bit, you'll probably find that fades away to nothing. Yeah. So yeah, tis what it is. We have a low CRT. Pity. Whether that's good enough to produce a picture, who knows. These testers, especially for the colour tubes, because the shadow mask tube used a lot more energy, the guns draw a lot more current anyway, so this will always read sort of pessimistically on a black and white tube anyway, but this really isn't good. But we haven't got any shorts, so, and things might buck up, who knows. One thing I am going to do is I'm just going to use these croc clips, and I'm going to go between the EHT output to the EHT rectifier and the top cap of the line output valve, in this case a PL504A. Let me just confirm that. PL81, sorry, my bad. So I'm just going to put a bit of current through that EHT overwind. So there we go. So 5 watts through that winding, if you like. So it's 200 milliamps, 22 volts, and that should get that warmed up. Meanwhile, we'll just leave that CRT cooking for a bit, and I'll leave the clock on it. You can watch it in time lapse, see if it moves yet. So I don't know. Oh, there's my clock. Right, let's face it, it's pretty grim news on the CRT department, but you know what, it might improve with use. I did check a while ago the calibration of this, the leader, and it was pretty okay. I had a tube which read so good that I called it into suspicion, but no, it was measuring sort of correctly, so there you go. I've known stranger things. The other thing to remember is this is designed to read a colour tube, really, so it generally reads black and white tubes a little bit pessimistically, but let's box it back up. We've done all we can with that, and proceed with waking the rest of the setup. So you just pop the lid back on here. That can lift back on its shelf. Ooh. Right, so we've still got current passing through the line output transformer, which is getting to about 45 degrees. So that's getting warm, so that'll be displacing any moisture that's got in there. Like I said, it's not the usual kind of sort of tar coated transformer, so yeah, I don't suppose it's going to be that much problems, but they are renowned for failing. Let's give it every available chance. So yeah, we'll keep doing that. Let's have a little bit of a dust and a clear up next, and yeah, then we'll take a look at the circuit, because there's a capacitor we're going to have to remove before we think about applying power. And also, I want to, there's an electrolytic can up in there, and I want to sort of be able to reform that without the rest of the set coming on. So we'll look at that in a second as well. Right, let's get rid of this dust. Well, that's made a start. Yeah, things are a little bit cleaner now. Good. Let us now take a look at the circuit diagram and start preparing to put some power on. Okay, here's the service manual from Philips 17TG100U, and we can see here's the power supply. So we've got two rectifiers, two PY82s in sort of parallel there, providing our HT rail of 214 volts. This, by the way, here is the dropper section that's been poloed to death. We will need to do something with that at some stage. But for now, we've got C706 here. Right, that's straight across the mains. So that is going to have to get cut out. If we put mains across there, the chances are C706 will, you know, it'll object and fail, sometimes quite spectacularly. One thing I'm going to do is I'm going to also pull out, in fact, need I pull it out? No, I'm not going to pull it out. I'm going to clip the Dreadnought capacitor reformer onto this point here, so where our HT rail is, and gently reform these capacitors without applying mains, so we won't get any heater or anything, and we can't get a feedback through these rectifiers because one, they're cold, and two, they're out of circuit. They're back to front, sorry. So yeah, right, let's do that. So first things first, where is C706? Have we got a layout diagram? You zoom out a bit. Oh, you have, look. Right. C706. Now these are quite clever thing that Philips does here, is they put the list of capacitors and their approximate locations across the top here. Nope, it's not there. I do the same here, by the way, in the schematic part. Right, C704, 703, 708, 706. So it's down here somewhere. 706, 706, C706, C706. Right, let's go and find that in the real world. Right, so in the real world, C706, it is just above an EF85, which I think is that fella there, isn't it? Yep, that's our EF85, and just sort of beneath the dropper section. So that leads me to believe it's that there. So what I'm going to do is he's connected to the chassis at that end. So that means one side of our mains is tied to chassis, I would imagine. Yeah, and that's coming from our voltage selector switch. That's C706. I am just going to take a pair of cutters to that and then snip the other end. Not that we're ready to power up yet, but in the event we do, I want it out of circuit. What I should do is I should replace that with a modern X-class component. Right, so here we have the Mark 87B capacitor reformer. Its job is to reform those electrolytics. So what we do is we connect this end to our variable power supply, which is over here. I shall have to make some room. So essentially this is a low current variac with a it's an isolated as well, but it will go to quite high voltages. We get 500 volts out of it on a good day. And the reformer itself, let me just bring another camera on or two. So the reformer itself, it's got a meter movement which is measuring in microamps. It used to have a moving coil meter in there, hence the cap, but I bent the needle on it so many times. And we want to connect the output from this to that capacitor or that rail on the power supply, and then we can vary the amount of resistance there to limit the current going in. And we'll set this first off for about 200 volts, and then we can limit the current into the thing and gently reform that capacitor. So let's set about that. Okay, so sort of first things first, I've got this set to 0 ohms. I've got the meter on the output. Might be better if I've got the right probe. Okay, we've got the meter on the output, 42 volts currently. We want to just ease that up till we get to about 200 volts. You can't see that, the glare's too bad again. Oh, there we go, 170, 120. This, by the way, is the current being measured, drawn by the meter. And there's a capacitor inside the dreadnought. But let's wind that up till we get to 200 volts. Just going to discharge that rapidly and put it back on. See where we're up to. 203 volts. Near enough for me. So I'll just push this discharge switch. That causes it to discharge quite rapidly. There we are. And I'm going to dial some resistance in there. So one side to ground, so that could be our chassis, anywhere sort of sensible really. In fact, there's a chassis point where I just disconnected that capacitor, so that's nice. And then the other side of the dreadnought, so that can then go on to the output from our rectifiers. PCL86, where are our rectifiers? That's our choke. Rectifiers got to be these, haven't they? There they go. Yep. So that's our choke in between the two capacitors. I'm going to need to refer to the diagram again. So yeah, C708 is pin 3 of the rectifiers. So 1, 2, 3. Yep, and they're in series there. So I'm just going to snick on to the back of here on pin 3 with my little probe and see if this capacitor is going to behave. So that's more like it. Yeah, we're getting some leakage current now. So yeah, it's another job where we just leave this and keep coming back to it and lowering this until the sort of leakage has settled at some nominally small number. So I think we'll go back one. Hello, what have I bought on eBay? We're just going to leave it on 200 microamps for a little while and see where we get to. Right, let's pop back in a bit. Okay, so I left the capacitor on overnight. I know I shouldn't have done. It was possibly a risky thing to do. But I'd made sure we were in a sensibly current limited position, and I'd also measured the temperature of the can just before I went to bed, and it reformed beautifully. It didn't burn the house down, so that's good. That's why I'm doing these things, is so you don't have to. I also left the current running through the line transformer. To give you some idea, this morning the can on the Dreadnought Mark 87B capacitor reformer measured about 700 microamps. So yeah, it's quite a big can as well. It's 250 mic, 100 mic and 10 mic all in one. So there's a couple of resistances in between, but they were all measuring on or around 225 volts this morning. So I'm pretty convinced we're good to go with that. One thing that does concern me though, let's just have a quick look at the diagram. Oh no, before I do that, one thing whilst it was reforming yesterday, which I couldn't catch on the mic, was this capacitor here. This is between the primary of the sound output transformer and ground normally. You see I've snipped it. I was getting some crackling through the loudspeaker, just every now and again. Obviously it can't be coming from an amplifier stage because all our cathodes are cold, because there's no heaters. And it was this capacitor breaking down, so I snipped it, went silent. So we can cast doubt upon these sort of black tar covered capacitors, which brings me to the back and my concerns. Let me just pop the tube base back on. There we go. Let's put that back together a little bit. What is it? Oh, we take that off now. Don't need that anymore. And that earth, because that is our reforming gun. It's got stuck. There we go. Yeah, so I have some concerns of these two capacitors here on the rear of the set. Oh, you can see them on the camera quite well. This one here's got a bit of yellow tube around it, and there's another one there. Let's just have a quick look at the schematic on what they are. Okay, there's our power supply. I think we're done with, that's the can, and the other end of the can is off on the other part of the circuit diagram. The part that bothers me, this manual's all over the place. No, No, oh, there's the other part of our can. C703, it's 10 mic. Nope. No. Where's the part with the line output? Oh, of course, it's before the power supply, because all the pages are a bit higgledy-piggledy. Right, here's our boost HT rail. C609 is one of those capacitors, and 608. We'll just confirm that. 609, 608. Yeah, they're there on the layout. This is the line stage sort of life. 609 and 608. Those are exposed to the boost rail, and the boost rail, 600 volts at that point to ground, 500 volts at that point to ground. We lose any of those two, and we've got skyrocketing EHT. Could damage our line output transformer. We've already got a sad tube. I don't want a sad line output transformer as well, because that really will stop play. So, right, 608 and 609. Now we need to find that bit of the diagram with the capacitors listed. C608, 47 kpf. kpf. Okay, and 56 kpf. Is it kilo picofarads? Is that a thing? What does that translate to in real life? Let's Google that. 56 kpf. It's all in, yeah. kpf, it's going to be 56 nanofarads, isn't it? Let's fetch them out and have a look. But, yeah, 47 and 56 kpf. What a strange way of writing things. Never mind. Just to confuse me after a long day's work. C608, 609. Let's get them out and see if we have replacements. Right. Well, would you believe 56,000 puff? Struggling to read the rest of it. $56,000 picofarads. 350 volts DC. Quite clearly. You see that on there. Let's give it a light. $56,000 mic. Well, it sits on the HT rail. How can that be right? I think we'll find ourselves something suitably rated and get that fitted. Right. Right. Let's just have a look at what I've done here on Wobbly Can. Okay, so we didn't have a 56, so I've got a 47, and up behind it, right in there, there is a 720 tacked in, which gives us sort of 54 nanofarads. So we'll hope that'll do. Now I've just got to cut this fella out and change that, and then I think we'll be near enough to power up. If this one isn't near enough in value, we'll get something else. But what was the tolerance on the original? 20% plus or minus. So yeah, should get us in the ballpark if nothing else. Right, let's get on with changing the last one. This is this fella here. Let's get that out. So put that camera down for a moment because I can't work with one hand. Just snip him at the, snip him right by the body. There's a few of this type of capacitor in here. There's one there. There's probably more. It's one over here on the frame stage. So there will probably be other faults to put right. Let's have him out. Lovely. We'll confirm its value. I'll just cut that little rubber sleeve off. A bit crusty in there. Wonder why they chose to tuck it in there and not put it on this side of the tag board. Probably a reason. Ah, looks like that panel. Yeah, look. This panel actually pops out. It's on spring clips. Presumably that was assembled separately and then all the wiring married up with it. Oh, the other panel's on spring clips as well. They all are. How did I fail to notice that? The IF is on those spring clips. I think we'll leave them where they are. Right, we actually got a value left on this one. Yeah, we have. Well, at least this one's rated to 500 volts. 473, 500 volts. Can you focus on that? Let's give it some light again. Or you can take my word for it. Four 7 0 0 0 picofarads, 500 volts. So we can do better than that. We've got 4,700 at 2 kV. It's one of those CBB capacitors that we changed on the Pi that didn't put the Pi right, so we changed them back. So. Right, well, it's the big moment, isn't it? Let's wire some mains up, see what happens when we put some voltage on it. Okay. Just a few other preliminary checks. Just make sure the mains fuse is intact. It is. Is it? It is. And the 250 milliamp HT fuse is also good. Will they be so good in a minute? In fact, what I'm going to do is I'm going to put the meter on volts. Clip it to the chassis and onto the HT rail. So what do we say? 1, 2, 3. We're at pin 3 of the rectifier pair. Don't like the idea of rectifiers in parallel. Just seems very wrong to me. Anyway, so there we go. We can monitor the HT there. Come out a bit on the camera as far and wide as we can go. Mains lead plugged in. Okay. Now that's going to go into the connector block that is connected to a variable and isolated supply. So not only is it a variac, it's also isolated from mains. So the isolation transformer is being used to feed the variac. So we're doubly super. Let's move some of this out of the way a bit. Capacitor reformer, thank you for your service. You can go back on the shelf later on, perhaps. Okay. So let's spin the set round so you've got a view. It's a shame actually, because we need to see both sides at once, really, don't we? I may stop and move one of the cameras again. So, right, how much of that tube can you see? All of it. That's really good. That is really good. And then we'll get a camera in the back here. What a good idea. So I'm just going to repurpose and remove the cameras. Give me 1 moment, please. Right. Not only can we do that, look, we can have a little look at the HT while we're at it. Brilliant. Triple check everything. Yep, I'm happy. Variac is currently on 0. You can't see the mains volts, can you? Would it be beneficial for you to see the mains volts? I shall read them out as we go. Right. We can go pretty much up to 150 volts straight away, I think. Yep, 3, 4, 5. Volts. Let's hear our sound is up. Right, I'm listening for that distinctive 10 kilohertz line whistle this time. HT is at 78 volts. Oh, I can see nothing, but knowing the state this tube was in, that wouldn't really surprise me. Right, mains is now at 200 volts. Don't like the sound of that capacitor at all. Oh, we have a very distorted waveform. Hey, oh, no, something's arcing over there. Let's just be a little bit gentle with it. Yeah, something's arcing over, but we have a picture of some description. One thing I will say, there's something very wrong in the frame stage and the line stage. I hope it's not that yoke, but we've got a long way to go yet. We have first light, as it's called. Right, let's power that down. Let's just kill it completely. Oh, the spot. How wonderful. We have first light. That's great news. First things first, I think we better find out what's arcing over. Right. Hello. This camera is looking into our line output stage cage here. Where's my handheld lamp? One moment. So what we've got going on in here is the boost diode line output valve up there, so boost there, line there. This is our EHT rectifier down here. This is our line output transformer. So what we need to do is sort of watch carefully as the set comes up and watch in there to see where it's arcing over. I might just dim the lights for this test as well, because there we go. It'll it might show up a bit easier. The cameras are coping well, except for that one. Yeah, so excuse the grainy footage. Right, power is going on. I'm going to take her up to 200 volts fairly rapidly. And we're going to look in the cage for any obvious signs of arcing over. In fact, I tell you where it's going to happen. Now, let me just kill the power again. I'm betting myself it's that anode lead there, flashing over to the EHT. Right, let's try that and see if it flashes over. I've got a mirror in front of the set so I can actually see what it's doing. I'm encouraged by the results from the tube. Just shows how pessimistic a tube tester can be. Of course, we haven't got a decent raster out of it yet, but we'll see what happens when we do. Okay, you can see the valves are lit. We've still got no picture. Takes quite a while for the cathode, the line stage to warm up. Really don't like the hum at all. I wonder what's causing that, because I'd expect that capacitor to be better than that. Let's just carry on. I have a picture. She looks quite sharp as well. Oh, right. Where is it arcing over? I can hear it. Oh! There's a bit of a flash on top of that line output transformer. So, what's causing that? I do hope it's not the overwind. Right, let's go again. I can see it. It's that tag connector there arcing to something. Okay, I wonder what that does. It's off the top of the line stage somewhere. I wonder if this panel just needs to come out and have a little bit of a clean or something, because it's horribly filthy on the top there. And filth plus high voltage, they're not friends. It's good news though, really. We've got a CRT that's producing a picture. I'm not very happy about what the state of the mains can, but we can do something about that, I think. We should probably replace it with 3 discrete components. But we got a picture, and that's what they call first light. So that's going to be about it for this one. We shall continue on next time by cleaning out this cage, I think. Can the cage come off? Yes, I reckon it can. Right, thanks for watching. Stick around for the next one. It'll be very soon. Cheers now. look at this fantastic... Can't get my words out. First take ruined. Hello, welcome back. How you all doing? Hope you're keeping safe. Today we're going to be having a look at this Philips. Thanks, Odge Nodge. Love your channel. As you can see here, we've got UHF. No, let's do it all again. There, that'll do for the start for 6, won't it? I think so. Yeah.